everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over partitioning a line segment, one of our geometry topics, and it's very important that we memorize the rules on what to do, those steps. Because once we get the steps, we're going to be able to just keep going and going without even having to think about it to see what that point is that we're looking for. So let's start with the steps. So the first step is to add up that ratio. So they're going to give you a ratio of how that line is split. You're going to add up the first number and the second number, and we're going to use that as our denominator of our new fraction. So we add up those two numbers, we're going to use it as the denominator. Our first number in that ratio is going to be our numerator. So we're going to be creating a fraction. Once we have that fraction, we're going to look at our x's and see the distance between them. So this distance could be positive, it could be negative. I know we're saying distance isn't negative, but we're trying to see how far away they are from each other to be able to then multiply that number by our fraction that we found. So it's a little bit weird where we're like, wait, distance can't be negative. However, for this type of problem, we can get a negative number because we're moving it over. So we want to find the distance between the x and y values. Like I said, we're multiplying the number in step 2 by the number in step 3. So we're taking our new fraction and multiplying it by those distances. And then we are going to add those new numbers to our starting point. So if we're going from, let's say, A to B, we're going to add it to point A because that's where we're starting from to be able to figure out where we have to put our new point. Let's take a look at an example to make sure that we're seeing what we have to do here. So now we have the problem where it says the coordinates of the endpoints of segment A, B are such that A is negative 223 and B is 5, 9. Point C is on segment AB such that it divides it in the way of AB to BC is 5 to 2. We want to find point C. So for point C, we're going to start off with the first step, which tells us to add our ratio. So we're going to add 5 and 2 and make that a denominator of 7. Then we're going to take the first number here, which is 5, and put that as our numerator, because that was our step 2. Step 3 tells me to find the distance between my x's. So from negative 2 to 5, I'm moving 2 over to get to 0, and then 5 more over. If I do that, I'm moving a total distance of 7. So x's, I'm going to write 7, move 7. From 23 to 9, I'm moving negative 14. So I'm going to have y as negative 14. This means I'm moving down 14, which is okay. We're allowed to move downward. The next step they told us is to multiply our new fraction by our distances. So I do 7 times 5/7. The 7's cancel out and I'm left with 5. So I'm just going to write plus 5 here. Then I have negative 14 divided by 7 is negative 2 times 5, which is negative 10. So minus 10. Once we do that multiplication now, the last step tells us to add those numbers to our first point. So I'm going to do negative 2 plus 5. So negative 2 plus 5 gives me 3. So my final point C, is going to be 3, comma, negative 10 and 23. When I get that together, 13. So my final answer, the point C, that is in the ratio from AC to CB, 5 to 2, would be C is 3, 13. So hopefully once you were able to see these steps, it was a little bit more clear on how we would complete a problem like this. Let's try one more where we're going to use some decimals so you can see how we would complete something like that. Now for this problem, we're given a graph, so it's a little bit different. We're not giving the points, but they're telling us what ratio we have here. So let's first find the points so we're able to see what we're working with. So A is negative 3, 4, and B is 6, negative 1. And they want in the ratio 3 to 7. That's where our point D is going to be. So once again, we're going to take that 3 and 7, we're going to add them together. 3 plus 7 gives me a 10 in the denominator. In the numerator, we're going to take the first portion of our ratio, which is 3. Our next step is to find the distance. So to go from negative 3 to 6, we can even count on the graph. We're moving 3 over, and then 6 more over. So that's 9 for our x's. We're moving 9. For our y's, we're going from 4 to -1. So I'm going down 4 and down 1 more, which is -5. Now, once again, we're going to multiply our distances, like how far we're moving, by our new fraction. I'm going to leave it as unsimplified. Usually some teachers may prefer you to simplify, but at the end we'll still get the same answer. So I'm going to leave it as unsimplified. So if I do 9 times 3, I get 27. So I'll be adding 27 over 10. Now if I do -5 times 3, that's -15 over 10. Once again, I can't simplify this one, but I could simplify this one. But at the end, we're just getting a decimal anyway, so it doesn't matter if we simplify. Our next step is they're telling us we're going from A to B, because it's saying segment AB. So we're going from A to B, so we're going to add to point A. So I'm going to do -3 plus 27 tenths, and my y is going to be 4 minus 15 tenths. So let's put that in my calculator. I have 27 tenths, -3 plus that. My x from my point D is going to be -0.3, comma, and then we have the y, which is 4 minus 15 tenths, which is 2.5. So my final point is -0.3, 2.5. They're asking us to plot it. So if I look, -0.3 is like around here, 2.5 is up here, which is right on the graph, right around here, estimating a little bit. So as you can tell, our answer has to be pretty close to being right, because when we look on the graph and we're at 0.3, we go up, it is hitting at 2.5. If you get an answer where you plot it and you're like, wait, it's not even on the line, then something must be wrong. But once again, we're just using our steps. You could leave these as fractions, but if we want to plot it, it's a little bit easier to be working with these in decimals. So hopefully these steps were helpful to be able to see how you would complete a problem when you're trying to partition a line segment.